Good morning. Today's objective is to describe the transformation of a function from the parent function. And secondarily, we want to graph the transformation of that function. Today we're going to look at two functions, absolute value and quadratics. And we're going to do that just to introduce the topic. Once the topic's been introduced, we'll look later to generalize to any particular function. So let's first look at the absolute value function. Here we have the general form g of x equals a times the absolute value of x minus h, and then plus k. Then we have the parent function. We notice that in the parent function, there's no a, there's no h, there's no k. Now since the a multiplies in the parent function, a must be 1. And since h subtracts and k adds in the parent function, they must be 0. H and k actually turn out to be the x and y coordinates of the vertex of the absolute value function. So here, since h and k are 0, the vertex of the parent function is 0, 0. And then a being 1, that translates to the slope of the right-hand side of the absolute value function. So we can see clearly here that the slope is up 1, right 1, or just 1. So we can think of those as the default values of a, h, and k. So for the parent function, a equals 1, h equals 0, and k equals 0. That's for the parent function. So what we're going to look at then is the translation of this parent function. If you remember your geometry, your rigid body transformations where we can move the function left, right, up, or down. Okay. The left-hand side, just as an aside, the left-hand side here is just a mirror image of the right-hand side. So the right-hand side goes up and to the right. The left-hand side is going to go up and to the left. And if we're talking about mirror images, we want to know where that mirror is. We call that mirror the axis of symmetry. That axis of symmetry is here, x equals 0. It also corresponds to whatever the h value is. So that's how we can find our axis of symmetry. Okay. So when we're given a transformed function, the first thing we want to do is to identify the values of a, h, and k. Okay. Switch my pen here, make it smaller. Okay. And the vertex is going to be whatever h and k are. So we look at our function and we ask ourselves, okay, if I compare it to the general form, what is h and what is k? One way to think about h is you'll notice that h operates on the input. That is, it subtracts from the x before the function itself is applied. Here the function is absolute value. So we can look at this this 3 and ask ourselves, does it apply to the x before the function is applied? Well, yes, it does. So that means h is 3. Now don't be fooled by this minus sign here. You see there's a minus sign in the general form itself. So if you see an x minus h, then h is a positive value. Now there's nothing going on after the function is applied, the absolute value. So that means k is 0. And I don't see a number out front, but we know in multiplication, if we don't see a number, that number is 1. So then we expect the vertex to be 3, 0. And I can plot that. We expect the slope on the right-hand side to be 1. So I go up 1, right 1, up 1, right 1, up 1, right 1. So we can graph that. Okay. And then along with that then, the axis of symmetry must be x equals 0. And here my arrow is in the wrong direction here. Okay, so if we're asked, and you will be asked, to specify the axis of symmetry, we can simply indicate it as a dashed line. Dashed line because it's a feature of the graph, but it's actually not part of the graph. And we can label it as x equals 3. That's our axis of symmetry. And then we need to draw the other side. The other side is simply a mirror image So we're going to go up, whoops, we're going to go up 1 and left. Okay. And that is our absolute value function. Translated, how? How is this function different from that one? We can see visually that our entire graph has been shifted to the left by 3. And we can just compare vertices at this point. The original's vertex is at 0, 0. This one's at 3, 0. So the transformation is a shift right 3. Okay. And that is determined by the value of h. You notice here h is 3 and the shift is 3. Now h is actually a shift in the horizontal direction. Since h is positive, we might ask ourselves, okay, in which direction are all the positive values? Well, the positive values are to the right, so then that's where the direction comes from. H is positive, it's shifting to the right. The value of h is 3, I'm shifting right 3. Okay? So h here is our horizontal translation. Okay? All right. Let's look at a couple more examples of horizontal translations. Okay, here we have x minus 2. You can identify the values of a, h, and k. A is 1. H is 2. Remember, x minus is part of the general form. So that makes h positive 2. And then k is 0. There's nothing going on after the function of absolute value is applied. So k is 0. So even before we graph this, we know what the transformation has to be. It has to be a shift. Okay, we're always going to use that word shift. H is positive, so we're going to the right. And the value of h is 2, so it's a shift right 2. Okay, we always start by graphing the vertex first. So our vertex is going to be 2, 0. You can plot that. And then let's our slope is still 1, because that's the value of a. And then let's put in our axis of symmetry. Oh, you know what? I wanted that a different color. Let's do it in blue again. Switch to blue pen. X equals 2. That's our axis of symmetry. Okay. And then finally, this last one here, still sticking with the horizontal translation theme here. Got the word shift. Okay. Now we're going to go to the right or the left. Now this was minus. We said that minus is part of the function, so we're going to the right. Here, a is 1, but now h, well, that had to be negative 4, because that's the only way we can change this negative sign into a positive. We subtract a negative, that's the same as adding a positive. So h was negative 4, and then k here again is 0. Now, negative 4. If I'm at the origin, the negatives are to the left, so that's a shift to the left. I'm going to go left 4. So we start by doing the vertex. The vertex is negative 4, 0. We can plot that. Let's put in our axis of symmetry. Okay. say, give the equation of the axis of symmetry. Okay, and then let's draw in the rest of the graph. Whoops, I don't want blue, I want black. And that's our translated function. Okay. Now, just an aside, here's some things that are important. Okay, if you're doing this on a test, okay, how big is this? You need to tell me what the vertex is. Okay, either have it plotted correctly or just tell me what the vertex is. If I ask you for the transformation, you need to tell me shift. I need to see the word left or right, and then I need to see the number. So those are important. You need to give me the axis of symmetry. Okay, if you're asked for the axis of symmetry, I want the equation. Don't just give me a dashed line. I want the actual equation of that axis of symmetry. Okay, so this is completely graphed. I have the vertex in the correct place. The slopes are correct. I have the axis of symmetry drawn and the equation of that axis of symmetry given. Okay, and that is horizontal translations. Now I'm actually going to switch to quadratics to look at the vertical translations. Okay. Now this is a recording, so if I'm going too fast, just pause and rewind, right? That goes without saying.